vapor pressure. So what is the main importance of the colligative properties means? By using the colligative properties, if you know the one colligative property means we can calculate the other colligative properties. At the same time, so we can calculate the molar mass of the solute present in a solution also. By using the colligative properties, we can calculate, okay. So we can calculate the molar mass of the solute present in a solution also. Okay, so for that one, so directly, sir, what is the relative lowering vapor pressure? How we are going to derive the relative lowering vapor pressure equation means here? So based on the Raoult's law, we are going to derive the relative lowering vapor pressure. Sir, what is the formula we are getting for the relative lowering vapor pressure means? Okay, you can get one formula here that I'll show you here. So P naught minus, so P naught minus, so PS by P naught is equal to, so WB by MB into, so MA by WA. So that means how we can write here, before that one more equation will get us here. What is the equation will get us means here? P naught minus PS by P naught is equal to mole fraction of the solute. Sir, how we can write as a mole fraction of the solute means mole fraction of the solute is equal to NB by Na plus NB. NB by Na plus NB. Okay. Now, so here in this one for the dilute solution, in denominator part, NB value is negligible. The denominator part, NB value is negligible. If it is NB value is negligible, that means we can write as a P naught minus PS by P naught is equal to NB by Na only. Na? So in that also NB and Na. NB and Na are nothing but number of moles of the solute and number of moles of the solvent. How we can calculate the number of moles of the solute, Ritu? How we can calculate the number of moles of the solute? How we can calculate the number of moles of the solute? Must they join?
Sir, could you repeat again?
So how we can calculate number of moles? Hi Aditi, Kathy. Hi everyone.
Hello. Mass of solute by molar mass.
Yeah, yeah, ma. So mass of the solute by molar mass. So if you take the
Yes.
mass of the solute or given weight by molar mass is we can calculate as a number of moles of the solute. So by substituting this one, we'll get the formula is this one. So based on this one, I gave one calculation. So Aditi and ma. So Aditi, Kathy, have you completed this question? I gave options also. How many members have completed this question, ma? How many members you completed, ma? Question. Number
I
of
didn't
moles.
get it, sir.
Number of moles only we are getting, na? What is the answer you got, ma? Kathy.
I didn't get it, sir. I got number of moles as 9.9. I didn't get after that.
So once can explain it, I didn't get the answer.
Ma. So in this question, vapor pressure of the water they had given. What is the vapor pressure of the water? They had given 19.8 mm and 0.1 mole of the glucose also they had given. Okay. And 0.1 mole of the glucose is dissolved in 178.2 grams of the water. Okay. Then, so what the question they're asking means, what is the vapor pressure of the resulting solution? So what is the vapor pressure of the resulting solution means here, we have to calculate the PS value. Okay, so we have to calculate PS value. Okay, so how we can calculate the PS value means, let us see first. First, we have to calculate the number of moles. Number of moles of the solute already they had given. How much they had given? 0.1. Okay, now we have to calculate the number of moles of the solvent also. How we can calculate the number of moles here? 178.2 2 divided by 18 grams here. Molar mass of the water is equal to 18. So for that one, you are getting as a 9.9 here. So what is the value you are getting? Number of moles of the solvent means we are getting as a 9.9. Okay. Now if you substitute the number of moles in the above equation, if you substitute the above equation, what is the P naught value? P naught value is equal to 19.8 minus of PS divided by 19.8 is equal to 0.1 divided by 0.1 plus 9.9. So 9.9 means how much will get? 198, 19.8 minus PS divided by 19.8 is equal to 0 point divided by, I think so we'll get as a 10 only now value. 9.9 plus 0.1 we'll get as a 10 only. So how much will get the value? 10. So 0.1 divided by 10 means we can write as a 10 power minus 2 now. We can write or not, ma? 10 power minus 2 we can write. Can write or not? Okay, now we can simplify this one, ma. Here, 19.8 minus of PS is equal to 19.8 into, in this one you will get as a 10 power minus 2. 10 power minus 2. Okay, into 10 power minus 2. If 10 power minus 2 means how much value will get? What is the value? 19.8 divided by 100. 19.8 divided by 100 means I think so we'll get as a 0.198 only now. What is the value you'll get, ma? 0.198. So then PS is equal to 19.8 minus of 0.198. 19.8 minus of 0.198. So 19.800, okay, and 0.198. 198 means how much you'll get? 2, 0, and you'll get as a 6. 19.602 is the answer I got. So what is the answer I got here? 19.602 is the answer I got. And so check it out. His option is there or not in the question? I give options also. So A option, B option, C option, D option. So what is the correct answer for this one? What is the vapor pressure of the resulting solution means? 19.602. Still anyone you are having doubt? Aditi. So what is the answer in this one means? The answer is B is the answer. So how many members you tried? No one is tried, huh?
So I tried, but I didn't get the answer.
You got the answer, Aditi?
So I got it now.
Okay, good, Aditi. Next, Kathy.
Sir, I just could reach till the number of moles. I didn't know what to do after. Now I understand.
Okay, now you understood, ma? Kathy.
Yes, sir.
So this is the JEE level question, ma. This is a JEE level question. Okay. Next, Ritu, do you understand this one?
Yes, sir, I understood.
Okay. Next one. Then we'll go for the next concept. So what is the next concept we are having means here? So we'll go for the elevation of boiling point temperature. Okay. Elevation of boiling point temperature. In some books, they had given elevation in boiling point temperature. Okay. So what is the next concept we'll discuss means? We'll discuss about elevation of boiling point temperature. Elevation of boiling point temperature. Okay. So right now. So in this one. Here Before going to the elevation of boiling point temperature, first of all, what is meant by the boiling point temperature? That is my question. Any one of you. What is meant by the boiling point temperature? Ma, how we can define the boiling point temperature? Any one of you. What is meant by the boiling point temperature? What is meant by the boiling point temperature? I'll give the definition. So what is meant by the boiling point temperature means the vapor pressure of the liquid is the vapor pressure of liquid is vapor pressure of liquid is equal to atmospheric pressure, equal to atmospheric pressure, atmospheric pressure. Okay, so how much it has to be there means 1.013. Okay, so 1.013 bar it has to be there. Okay, the vapor pressure of the liquid is equal to atmospheric pressure, means that only we can call as a boiling point temperature. Okay, so what is meant the boiling point temperature means the temperature at which the vapor pressure of the liquid is equal to atmospheric pressure is called as a boiling point temperature. Every liquid it has a particular boiling point temperature. Every liquid. So all the liquids are having particular boiling point temperature. If you compare with the pure solvents, so pure solvents are having high boiling point temperature. Okay, so here what is the condition means here pure solvents, pure solvents, pure solvents are having high boiling point temperature. Pure solvents are having high boiling point temperature. So why the pure solvents are having high boiling point temperature? Any one of you? Any one of you, what happened? Why the pure solvents are having high boiling point temperature? Sorry, ma. So pure solvents are having high vapor pressure. Pure solvents are having high vapor pressure. Pure solvents are having high vapor pressure. High vapor pressure. Vapor pressure. Okay, so pure solvents are having high vapor pressure. Then what about the solutions? So for pure solvent, so when you add non-volatile solute, the vapor pressure is going to be increases or decreases? For pure solvents, if you add non-volatile solute, Kathy, Ritu, Sai, Akshit, Sirisha, Samhita is absent today. Okay, ma. So in this one, any one of you, Aditi, Ritu, Kathy. So you all are attending the regular classes. Now what I'm telling that, so pure solvents are having high vapor pressure. If the vapor pressure is equal to atmospheric pressure, mean then you will get as a boiling point temperature. Now my question is for the pure solvents. So whenever you add non-volatile solute, the vapor pressure is going to be increases or decreases? Aditi?
Sir, it decreases.
Very good, Kathy. So by adding the non-volatile solute to the pure solvent, vapor pressure is going to be decreases. Sir, why the vapor pressure is going to be decreases means because of some solvent molecules are replaced by the solute. Okay, so when the solute molecules are occupied means surface area is going to be decreases. If the surface area is decreases means vaporization also is going to be decreases. If the vaporization is going to be decreases means vapor pressure also is going to be decreases. So due to that reason only solutions are having Due to that reason, solutions are having low vapor pressure. Low vapor pressure. So due to that reason, solutions are having low vapor pressure while comparing with the pure solvent. Okay. Now, in this one, if you see means, so to increase the vapor pressure, so what we have to do, we have to heat at high temperature only now. Okay, so to increase the vapor pressure, because of if the temperature is going to be increases, vapor pressure also is going to be increases. Okay, solution here having the low vapor pressure. To increase the vapor pressure, if we heat at high temperature, if the temperature is going to be increases, means vapor pressure also is going to be increases. So that's why solutions are having high boiling point temperature than at of the, so pure solvent, boiling point temperature of the pure solvent. Okay, so which are having the high boiling point temperature? Solutions are having high boiling point temperature. Okay, solutions are having high boiling point temperature. High boiling point temperature than pure solvents. Pure solvents. Okay, now in this one. So the boiling point temperature of the pure solvents can be represented with T0. The boiling point temperature of pure solvents. Pure solvents can be represented with T0 here. And the boiling point temperature of the solution can be represented. The boiling point temperature of the solution can be represented TB. Okay, so based on this one, let us see. So which one is having the difference between the boiling point temperature of the pure solvent and boiling point temperature of the solution? Usually we can call as a elevation of boiling point temperature. Elevation of the boiling point temperature can be represented with delta TB, sir. How we are going to represent the elevation of boiling point temperature? Elevation of the boiling point temperature can be represented with delta TB. Sir, how we can define the elevation of boiling point temperature? Means elevation of the boiling point temperature is defined as it is the difference between, okay, it is the difference between the boiling point temperature of the solution minus the boiling point temperature of the pure solvent is called as a elevation of boiling point temperature. So got it here, all of you? All of you got it or not?
Sir, could you repeat the definition?
So once again, I'm repeating the definition. Okay. So elevation of boiling point temperature is defined as it is the difference between the boiling point temperature of the solution and boiling point temperature of the pure solvent is called as a elevation of the boiling point temperature. Elevation of the boiling point temperature can be represented with delta TB. Elevation of the boiling point temperature can be represented with the delta TB. Okay. Now, so before that, we discuss some point here. Colligative properties are depends upon the number of solute molecules present in a 1 liter of the solution. If the number of molecules, sorry, 1 kg of the solvent. Okay, so the number of solute particles present in 1 kg of the solvent, that we can call as a molality only now. So we can call it as a molality or not. So what is meant by the molality? What is meant by the molality, ma? What is meant by the molality?
Number of solutes present in 1 kg of solvent.
Number of moles of solute present in 1 kg of the solvent is called as a molality. So elevation of the boiling point temperature also we can explain based on the graph also. Sir, how we can represent means here, let us see, ma. I am taking as a vapor pressure on the y-axis and temperature I am taking on the x-axis. Okay, now let us see. It is atmospheric pressure. So this one we can consider it as a atmospheric pressure. So what is meant by the boiling point temperature means the vapor pressure of the liquid is equal to atmospheric pressure is called as a boiling point temperature. For example, first I had taken as a pure solvent. So this I had taken as a pure solvent. So pure solvent is having atmospheric pressure is equal to that I am considering at T naught. So whatever the pressure it is there, that I am going to be considering it as a P naught. So this I am going to be considering it as a P naught. Okay. Here we are going to consider it as a P naught pressure. Okay. The vapor pressure of the pure solution. Okay. This also pure solvent we can consider it as a P naught. So that I am going to consider it as a P naught here. Okay. Now here for this only I am adding as a solvent. Sorry, solute I am adding. So whenever I add solute, the vapor pressure is going to be decreases. Okay, the vapor pressure it came here. So here that we are going to consider it as a P1. So this is the P0. So this is an increasing order. If you compare with the P0 and P1, which one is having the high value? Which is a high vapor pressure? P0 or P1?
P naught, sir.
So P0 is having the higher vapor pressure. So which one is having the high vapor pressure? Means solvents are having high vapor pressure. Okay, solutions are having low vapor pressure. So why the low vapor pressure they're having means because of, okay, so because of due to the presence of the solute molecules. Solute molecules are they decreases the surface area. Surface area decreases means vaporization also is going to be decreased. So that's why vapor pressure also is going to be decreased. To increase the vapor pressure or to increase the vapor, so what we have to do? We have to rise the temperature only. Na? So initial temperature is solvent temperature is T naught we had taken. And if we heat little bit slightly, if you are going to heat, okay, by heating at TB temperature, the vapor pressure also is going to be increased and boiling point temperature. So the vapor pressure is going to be increased as means the liquid is going to be boiled. The vapor pressure of the liquid is equal to atmospheric pressure. That place only the liquid is going to be boiled. Okay, so at the time here, so what is the temperature we are taking means TB. Okay, TB is nothing but boiling point temperature of the solution. T naught is nothing but boiling point temperature of the solution. Sir, how you wrote as this one here? Delta TB is equal to, so TB minus T naught. Okay, TB minus T naught. So TB is nothing but, so boiling point temperature of the solution minus and boiling point temperature of the pure solvent. And this also, delta TB is equal to delta P also. Sir, what is mean by the delta P means change in pressure. So change in pressure means how we can write delta TB is equal to, this one also we can write. So in place of delta TB, we can write as here, delta TB is we can write as here, TB minus T naught is equal to, and in this one, which pressure it is there more? P naught minus P1 also we can write now. So P naught minus P1, where we had seen here, it is the difference between the vapor pressure of the liquid and vapor pressure of the solution. So which one it is going to be explained here? So this one is explained by, so Raoult's law only now. Okay, it is going to be explained based on here Raoult's law. According to that one, how we can write means here, so delta TB is directly proportional to delta P. Okay, so delta TB is directly proportional to, we can write as a delta P. So according to the delta P, according to the Raoult's law, the partial pressure of the solution is directly proportional to the molality of the solution. Okay, the vapor pressure of the solution is directly proportional to molality of the solution. So that means in place of delta T, what we can write? Delta TB is directly proportional to, we can write as a M. Okay, in this one small m is nothing but molality. To simplify the equation, what we can write? Delta TB is equal to Kb into M we are writing. Delta TB is equal to Kb into M we are writing. In this one, what is meant by the Kb? Kb is nothing but, so elevation boiling point constant. Okay, elevation of boiling point constant. Elevation of boiling point constant. Okay, and this also we can call as a ebuloscopic constant. Ebuloscopic constant also we can call ebuloscopic constant. Okay, this also we can call as a ebuloscopic constant, and this also we can call as elevation of boiling point constant also we can call it here. So which one? Kb. Okay, so how we can define the Kb value? So according to that one, how we can write the Kb value? Kb is equal to, how we can write, delta Tb by m. Delta Tb by m. In this one, m is nothing but molality. M is nothing but molality. Okay, so this also how we can define the ebuloscopic constant mark. Based on the formula also we can give one definition. How we can define the ebuloscopic constant definition? This is the formula. So ebuloscopic constant is defined as it is the ratio of elevation of the boiling point temperature and molality. Okay, and what is the another definition we can give means here? Sir, ebuloscopic constant is defined as ebuloscopic constant is produced by dissolving of 1 mole of the solute in 1 kg of the solvent. Okay, so how we can define the ebuloscopic constant or elevation of the boiling point constant means the elevation of the boiling point constant can be produced by dissolving of 1 mole of the solute in 1 kg of the solvent is called as a elevation of the boiling point constant. What are the units of the elevation of the boiling point constant? What are the units, ma? What are the units for the molality? First of all, what are the units for the molality?
Some molality or molarity?
Molality, ma. Small m is represented as a molality.
Sir, mole per kg inverse.
Okay, ma.
Mole kg
So
inverse.
temperature means we can write as a Kelvin only, na? What are the units of the temperature? Units of the temperature is equal to Kelvin. Kelvin divided by, so mole per kg. Okay, so mole per kg. So if we simplify this one means we can write as a Kelvin kg and mole inverse. So what are the units we will get as means here? So Kelvin. So what are the units of the ebuloscopic constant or elevation of boiling point constant means Kelvin, kg and mole inverse. Anyone you are having doubt here? So how you are getting as a Kelvin kg inverse means here mole per kg it is there. In this one Kelvin into, if kg it comes to the numerator part, it is present in the denominator. To simplify that one means it comes to the numerator part divided by moles. Okay, now if you simplify that one means also we can write as a Kelvin kg mole inverse. Sometimes they're asking the units also. So what are the units of the ebuloscopic constant? What are the units of the ebuloscopic constant means Kelvin kg mole inverse also we can write. Okay, and thermodynamically how we can define the ebuloscopic constant? Okay, so how we can define the ebuloscopic constant thermodynamically? Among this formula also we can simplify means we can write in another method. What is another method we can write here? Delta Tb is equal to Kb into, how we can write the formula for the molality? How we can write the formula for the molality? Molality is equal to weight by molecular weight into 1000 divided by weight of the solvent. Weight of solvent. So that formula also we can write. Okay, Kb into weight into 1000 divided by, okay, 1000 divided by, so molecular weight of the solute into weight of the solvent. Weight of the solvent. So all these formulas we are using in the calculation part, don't get confused. So clearly once you check it out. So once again I'll scroll down the screen also. Formulas are very, very important in the calculation part. Okay, sir, elevation of the boiling point temperature is directly proportional to the delta P value. According to the Raoult's law, okay, the vapor pressure of the solution is directly proportional to the molality. Okay, so there we are taking as a mole fraction. So mole fraction also independent on the So temperature. So in place of mole fraction, we are taking as a molality. Okay. Now delta P is directly in place of delta P, we are writing as a molality. So to simplify that one, how we can write delta B is equal to Kb into molality. Okay. So what is the molality means number of moles of solute present in 1 kg of the solvent. To simplify the whole equation means we'll get as delta TB is equal to Kb into Wt into weight of the solute into 1000 divided by molecular weight of the solute into weight of the solvent. All of you got it here? Okay. Right, ma'am. So now here thermodynamically, so Kb, how they are going to be represent the Kb value? JEE point of view. So JEE point of view. So thermodynamically, how we can define the Kb? Thermodynamically, so Kb is equal to R TB square divided by 1000 into LV. Okay, 1000 into LV. In this one, R is nothing but universal gas constant. R is nothing but universal gas constant. Okay, and what is going to be the TB? TB is nothing but so boiling point temperature of the pure solvent. Boiling point temperature of pure solvent. Okay, and LV is nothing but latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. This also we can write in place of LV also we can write as here delta HV by M also we can write. Okay, so what is meant by the M is nothing but molar mass of the solute. Okay, molar mass of the solute. Okay, so now you can check it out. In place of this one LV also we can write as the formula. Okay, so now according to that one, let us see. If you write the formula means how we can write here Kb is equal to R delta B square M divided by 1000 into delta HV also we can write. Enthalpy of vaporization. So what is meant by the delta H means here? Delta H is nothing but enthalpy of vaporization. Got it here all of you? So shall we try one question here based on this one?
Yes.
So can you revise the formulas all? Just 1 second. All of you got the formulas here? So then can I give the question? My laboratory, how we are going to calculate? So elevation of the boiling point temperature means what is the method we are using means here Landsberger method we are using here. Okay, in laboratory, so lots note, it is an important point here. In laboratory, delta TB can be measured by using Landsberger method. Landsberger method. Okay, so I think so it is not required sometimes because of they're asking the question JEE question here. So what is the method we are using to calculate the elevation of the boiling point temperature in laboratory? What is the method they are using? It's a Landsberger method they are using. Okay, Landsberger method, Cottrell method it is there. The Cottrell method can be used to calculate the cryoscopic constant. That means depression of freezing point constant that can be used here. Okay. Now I'm giving one question to you based on this one. Let us see. What is the value means? Let us see one question, simple question. Calculate the molar elevation constant of water. Calculate molar elevation constant of water if 0.1 molality solution has 0.1 molality solution has the boiling point of 100.052 degrees centigrade. Okay, ma? So this is the question they're asking. They're asking calculate the molar elevation constant of water if 0.51 m molar solution has the boiling point is 100.052 degrees Celsius. In this one, so we have to calculate the Kb value. In this one, we have to calculate the Kb value. Okay. First of all, what is the data they had given? Any one of you? First, all of you read the question. All of you read the question. What is the values they had given? First, to tell me that. What is the formula and what are the values they had given? Aditi, which values are they had given in a question? What we have to calculate? Ritu?
They have given the boiling point and the
Sir, they've
molalities, no?
given
We have to calculate delta TV.
Molalities they had given as 0.1 molar. Okay. And boiling point, which boiling point? Either it is a boiling point temperature of the solvent or boiling point temperature of the solution. That means
Solutions
TB is equal
TB
to
and
100.052 degrees. Then what about the T naught value? What about the T naught? T naught is nothing but boiling point temperature of the solvent only, na? So what is the solvent they had taken? Water. What is the boiling point temperature of the water? 100 degrees centigrade.
100 degrees.
They're asking to calculate the Kb value. So how we can simplify this question? What is the formula? Delta TB is equal to Kb into M. In this one, delta TB is nothing but TB minus T naught is equal to Kb into M. Okay, so this is the formula we are using. Okay, now in this one, what is the TB value? 100.052 minus of 100 degrees is equal to Kb into 0.1. Now, if we simplify this one, means how much we'll get? What is the answer you will get, ma? Kb value. Any one of you? What is the finally answer?
Sir, 0.52.
But 0.52 I had given 0.052.
So 5.2.
One second, ma. So I put the values different. This is 0.052 na. If you subtract the 100.052 means you'll get as a 0.052. So 0.052 divided by 0.1. That means how much will get answer? 0.52 is the answer you will get. What is the answer you will get as means? 0.52. I had a small mistake. All of you got the answer? All of you got
Yes,
it
sir,
or
got it.
okay? So
Yes, sir.
then I'll send some questions mark. All of you having previous year papers questions are there with you? Any Arihant or something? Previous JEE questions? I'll do one thing. I'm having some soft copy. I'm forwarding to you in a group. Better to practice the questions from that. Otherwise, I will take the snapshot and I'll forward the questions to you. You can